My name is Jim Barry. I'm a senior scientist at the Monterey Bay Aquarium Research Institute, and I'm a marine ecologist that studies deep sea animals. Davidson Seamount is an undersea mountain that is located about 100 miles southwest of Monterey Bay, and it is an inactive volcano. It last had activity probably 20 million years ago, and it rises off the seafloor at about 4,000 meters depth up to below the surface. It does not broach the surface, and to get to the top of Davidson Seamount, you have to go down 1,500 meters below the surface. Well, to explore Davidson Seamount, and especially to get to any of those depths, you need robotic submersibles or human-occupied submersibles to go down and get a look, to make measurements, to view some of the amazing animals that live on the seamount and around it. In 2018, there were as funded by the NOAA's Ocean Exploration Program, Nautilus Live was performing a remotely operated submersible dive. That's an unoccupied submersible that's linked to the surface by a tether. Scientists sitting in the van or sitting looking at video screens. The pilot is moving along the seafloor with the robot, and you have to sort of picture how it works undersea, and all you can see is what's out in front of you in the headlights of the remotely operated submarine. And so it's like exploring on a hillside at night with no moon, with just a flashlight. And as this sub was crawling across the seafloor, swimming or floating above it, just a few meters above it, out of this darkness emerges an octopus or two or three, and then suddenly hundreds of octopuses, a discovery that was unprecedented in terms of the number of octopuses on any location on the planet. And the question was, what are they doing there? And the first thing they noticed were these kind of opalescent whitish octopus against a dark background. But when they moved in closely to get a close-up view of these octopus, that's when they noticed the shimmering water. And that shimmer in the water indicated that there must be probably some warmer water oozing from the seafloor, a thermal spring of some sort. And immediately, those investigators thought, wow, maybe this thermal spring has something to do with the reason that these octopuses were there. And they noticed that all of these octopuses, or rather most of these octopuses, were females brooding eggs. So this is a breeding ground for these octopuses. And the question for deep sea ecologists and biologists is, why are they associated with these thermal springs? And that's what we set about to try and figure out over the last few years. Most of these octopuses are brooding young, and most of them also, we found, were brooding only in those areas where there was elevated temperatures. The temperature of the water in this area is about 35 degrees Fahrenheit, or about 1.6 degrees centigrade. Very cold water. For cold-blooded animals, their metabolism slows down with cold water. And so we felt that maybe the benefit of these thermal springs is that it made these octopuses more able to develop more rapidly, and there would be some reproductive advantage to developing so quickly. We used temperature sensors that were deployed by these robotic arms on this robotic submarine, and the pilots that are sitting in the ship above were able to position those sensors directly adjacent to some of the eggs within many nests. And we found that the waters around these, or inside these nests, were about 5.1 degrees centigrade, or about 40 degrees plus Fahrenheit. So not hot, but certainly quite a bit warmer than the ambient waters in the area. Over several expeditions to the seamount, we were able to document how fast some of these embryos were developing in these nests. And what we determined was that they were developing from eggs to hatchlings in about 1.8 years, far faster than what we expected in those cold waters in the deep sea. Normally, at those very cold temperatures, we may expect that animal to take 5 to 10 years plus to hatch their eggs. But they look like they get a large reproductive boost from the warm waters found in these springs. I was born in Missouri, the center of the country, nowhere near an ocean. And fortunately, my family moved to the coast of California when I was a young boy. And in crawling around the beaches, surfing, looking at the life around the shoreline, I was fascinated with animal life and how it related to different parts of the ocean. And I just decided to keep studying biology and oceanography, and it eventually led to a career in oceanography and science. I went from surfing along the coast to studying the animals that live below the waves.